Sega and IBM's attempt at a Mega Drive PC mashup appeared in the Cave recently, a Japanese exclusive from 1991 that, as we learned in part 1, might be more than simply two individual systems in one box. With no fewer than 3 CPUs and that Mega Drive chipset, could PC and console gaming work in harmony to deliver something truly unique? Well, today I'm hoping to answer that question, assuming we can fix the thing, and we will get some insights from developer RetroSwim, who's also been working on the problem and trying to answer that very same question. And we'll get to meet him later. Hello Cave Dwellers, welcome back into the cave for part 2 of this series on the Sega Teradrive, a system that I just want to hug and squeeze. It's beautiful, and it will be even better when it actually switches on, and that's what we're focusing on today, getting it working, hopefully demonstrating it to you. Now at the end of part 1, and if you haven't seen that, there will be a link below or somewhere above my head up here that you can click on to go and watch part 1, where we learned about its background, what it cost, who it was aimed at, and ultimately that it failed. I mean, it doesn't take a genius to guess that such a thing was not a commercial success, and that's all in part 1, so go and enjoy that. We left the end of part 1 with the PSU in the capable hands of Holly because we found it was giving a funny output and the system wouldn't fire up, and we did see some pretty nasty looking capacitors on there, and Holly wanted a bit of extra time to actually check it out fully and make sure that she could give it back to us confident that it wasn't going to cause damage to the system. So let's pick up where we left off. How did you get on with that, Holly?
So when we replaced that capacitor, I powered on and found that it wouldn't sustain an output. So checking the positive feedback circuit, which is that transistor and also coupler, I found they were damaged. So I replaced those and retuned it, and now it's working.
I decided let's put the whole system back together, all the nuts and bolts and screws, and just believe in the power of Holly's magic that she saved the day. Yeah, and I noticed as I was doing this that being IBM built, it's very well thought out in the way it's put together. It feels solid, and certainly more solid and robust than the Amstrad Mega PC. It feels like a much better put together machine. Let's hit the magic power switch now and see what this thing can do. Or maybe not. I've got no power light, and I've got no sign of life on the keyboard. I would at least expect the numlock to flash or something like that, like a normal PC when it turns on, but there is nothing. There's nothing on the Mega Drive side, and there's nothing in PC mode. Now Holly says that the PSU is in good working order, so if that's okay, this is not a good sign at all, and I'm going to have to take all those screws out again and check it over. You'd think I would have learned by now, honestly. It's that part of the episode where I say a big thank you to PCBWay.com for supporting the channel. If you're working on your own project and you need PCB manufacturing, 3D printing, CNC work and much more besides, then PCBWay.com is the place to go. And while you're there, make sure you check out their shared project section, which is just rammed full of projects to support vintage hardware. It's well worth a look. Thank you, PCBWay.com. So let's start again. I measured the voltage on the board as it's coming in from the PSU, and it's low. My 5-volt lines are less than half what they should be, and my 12-volt lines are reading around 9. For my own sanity, I did check the PSU again off-load to just make sure it's putting out what it should, and of course I shouldn't have doubted Holly, but you know how it is when you're diagnosing things. You just want to make sure you're not spending days on a complex fix when a simple one might be staring you right in the face. I then checked to see if anything was getting especially or unusually hot in the case, as this can be an easy way to identify where the problem is. And yes, we are looking at a PC here and not aerial footage from a war zone, as it kind of looks like. With the system powered on, I can see heat. The whiter areas are the hotter areas. These are the chips warming up. And the hottest is the 286 CPU, but it doesn't exceed 40 degrees, which is well within normal operating temperatures. So nothing jumped out at me here as being a cause for concern. And the fact that they're heating up suggests that there is life going through this machine. It's in a coma rather than a grave by the looks of it.
Rise from your grave.
And then, well, as I scratched my head and sipped my tea, I noticed something was happening. The voltage was slowly creeping up, very slowly, but it was creeping up. So I thought I'd just sip more tea and wait and see what happened. This is an indication that the capacitors in the system, which have been dormant for I don't know how long, maybe decades, are starting to reform. What this means is that our capacitors, which have an aluminium oxide layer, that layer dissipates if it's not exposed to voltage over time, and then by applying voltage, it can help that layer to form again. And something was happening. The system was trying to wake up. We've got an image flickering on the screen here, on and off, as it just resets. And then never have I been so pleased to hear Sonic the Hedgehog before. The 5 volts have locked in at around 5.06, 5.05 volts, and the system is working, or at least it worked for a bit. Yeah, I'm glad I grabbed my phone at this point. Sorry about the slightly shaky footage, but I just wanted to capture it when it happened to show you because it didn't last long at all. When I turned it off and on again the next time, our voltage had dropped. And this time it wasn't coming back up and it wasn't coming back to life. So what we think's happened here is that while some capacitors have reformed, others are likely dry, or maybe they've leaked. And those that did spring back to life have probably put stress on those that were clinging on for dear life. Even if it did turn on again, it's not really a solid long-term solution to cross our fingers and hope for the best. But it did prove for a moment that the Teradrive isn't beyond saving, and that really enthused me. But I do think the next course of action is going to be to remove the board again, get comfortable and replace all 60 or so capacitors on the system board so that I've got peace of mind that they're all good and this has all been fully recapped. So let's do that now. I started by documenting what they all are so I could make sure that I had stock, and then I desoldered them one by one. I also resorted to my electric solder sucker. Now this isn't the same as a desoldering gun. This is a heated tip with a manual solder sucker built into it. You have to cock it by hand between every use. It's much cruder, but I had a 1mm tip with this which worked really well with the pads on this board. It really got things flowing easily and it made really short work of clearing out the holes. I will put a link to that tool in the description, but it's hard for me to fully recommend it because while it does get those stubborn holes cleared, it also has a habit of destroying its own tip after about only 50 or 60 hole clearances. It's a right pain in that respect, and when tips are about £2 each, it can get expensive on a big job. So it's a bit of a last resort tool for me. This just gets the job done for me, and we're ready for the new capacitors. The ones I'm putting in are mostly Panasonic branded, but we have got a couple of Nichicons thrown in, and slowly but surely I repopulated the board. There's also that hard drive. Now I noticed some pretty unhappy surface mount caps on that, which when I looked closely, they were leaking. There were leaky patches around them, especially that one on the left-hand side here, and green crust forming. They were definitely leaky caps. It didn't look good. And I tend to retire old hard drives because, well, they do all crash in the end. They can't spin forever. And there are modern solutions that just get the job done, especially when you have it in a hands-on demonstration display purpose like we're going to do with this Teradrive here in the museum. As I say, I won't be too upset if this doesn't work, but we will test it and find out. Back to the board, that's done now, and it wasn't too troublesome on the whole. It was just a lot of caps to work through. It was a board with a thirsty ground plane, so sometimes I used a bit of hot air to wave around and get the board warmed up before desoldering holes, but everything came out fine and we did no damage in the process. Okay, power on time. We'll check our voltages again. And this is looking very promising. We're straight up to 5 volts this time when we turn it on. No waiting for anything to change, for old caps to reform. It's just bang, straight into 5 volts, which is how we like it. And the 12 volt line is good as well there. So let's turn it on in PC mode with the hard disk plugged in. So we'll get that plugged in now. In goes the cable. And then in it goes the right way round. It is keyed, thankfully, so I can't put this one in the wrong way round. Power on, the light comes on. The system does come on, which is a huge relief, and the hard disk light is flashing. And there are also some promising noises from the hard disk. You can hear it spinning up and chuntering away, so it's really good. And it's so good to see the actual system itself turn on again. We've got a display and it's showing that it's found our 2 memory modules too, that's good. Come on hard disk, you can do it. And no, that's failed unfortunately. I tried it a few times, but it's not a happy hard drive, but that's okay. The system does seem to be in good working order now, with the exception of the hard drive, thanks to the recap. And I do have a solution already lined up for this scenario because I was going to replace the hard drive. So we'll unplug it, we'll leave it in there and have a well-deserved rest hard drive. So what we're going to use instead is this new device. It's called a PicoMem by Freddie V, and I purchased it from Flame Lily. Now that's my nearest UK supplier, but they do also ship to the rest of the world, and there are other suppliers around the world for the PicoMem, but Flame Lily do a great job. It's an 8-bit ISA card powered by a Pi Pico, and what it gives us is up to 4 virtual hard drives which are mounted from an SD card which goes in the back there. You can also have 2 virtual floppy drives, again where you mount image files, and that's your floppy disks working. It can give you additional conventional memory, up to 4 megabytes of expanded RAM, USB mouse and joystick support via the micro USB port on the back, and Wi-Fi networking. Yes, Wi-Fi network in vintage PCs. It's a wonderful card. It's a Swiss Army knife of ISA cards, giving you everything you need to get the most out of a vintage PC. I love this thing. It does mean that we've sacrificed the Sound Blaster card that was in there before, but that's okay because the system didn't come with one originally. And we do have options, which I'll show you once we've put it back together again shortly. So I was really delighted when this thing came to life after the recap, because it's a valuable machine, but it's also a machine which I think holds a lot of secrets, and I'm hoping to try and discover some of those, or at least start down a path of discovering some of its secrets today with a full test drive. So let's do that right now. First up, it's Mega Drive mode. Now you'll notice that I've got both the DualSync VGA monitor and a composite display plugged in, and they do both display at the same time in Mega Drive mode. The monitor, that supports 15 and 31 kilohertz modes, and of course everything looks super crisp on that display. It's really lovely. With composite output, it also does mean that it's not a lost cause if you've only got a 31 kilohertz monitor. You could just use the Mega Drive on composite on a regular TV, or perhaps you've got a very large TV in your lounge and the Teradrive nearby and you want to do some big screen Mega Drive gaming, and that's fine too. You can use your composite output for that. It's a nice option that's not an option included on the Amstrad Mega PC. And yes, just because it's a fancy rare computer, it doesn't make me any good at playing games on it. Sonic, Golden Axe, everything looked amazing on this system, and it really would have felt like a premium way of playing Mega Drive games back in the day. Not that that alone would have justified the cost though, but that's where the PC was supposed to come in, so let's switch over to PC mode. Now when I first did this, I had an unusually large font on the screen and it remained in 15 kilohertz mode. But after making sure the rear video switch was in the RGB position and resetting, it looked as I would expect it to on a normal PC. In PC mode, you first boot up to the IBM Sega menu with some interesting options on these blue tiles, including what looks like a screen to map a joypad to certain keyboard keys or key combos perhaps. Not quite sure how that works, but that's interesting, could be useful. I was also able to set the date and time correctly, so no Millennium bug to contend with here. There's also options to browse disks and to do a disk copy without even going into DOS. You can do that from here, but I'll choose the DOS option to boot the PC as normal. At this point you can see the PicoMem kicks in, there's a message on the screen there, and it's got its own BIOS that we can get into by pressing S, to configure it. Now, this is not a review of the Pico Mem, of course, but we'll have a flick through the menus quickly. And of particular interest is the disk menu. And this, you can see, is where I've mounted my main drive, and I've got a second hard drive image called my games image. You can guess what's on that one. And these are just .img or image files on the SD card. So long as you put them in a folder named HDD, then it will find them and you can select them. Likewise, as long as you put your floppy images in a folder called floppy, that's it, it will find them. I did wonder if we might get a virtual CD drive option at some point in the future and be able to mount ISO files. That would be brilliant if we could do that. On the memory page, we can enable all of the additional memory options to give our system a bit of a boost, and it all helps when you're talking about 286s and kilobytes rather than megabytes of RAM. And here's a fun one. This is the audio menu, and there is an ad-lib option. So there's an extra module that you can put onto the card, which I don't have, and that will also turn your card into an ad-lib sound card. So there's our option if we really want a sound card. I know it's not Sound Blaster, but it's an option, and I should do that in future, really. And if sound cards are your thing, then check out the Pico Gus, which is a sound card project, and it's really, really cool. But the Pico Mem is still very much evolving as a bit of hardware. As you can see here, it's version 0.4 we're using, so I'm excited to see what might happen next with it, what improvements and upgrades might be released, because being a Pico, it's super flexible. Updates could be absolutely anything. You could completely transform this card to do a different task altogether, thanks to the flexibility of that. So let's boot our PC up now, and it boots into my image of its DOS 6.22. Now, originally the Teradrive would have had DOS V for VGA, and it would have had Japanese language support. Now, I may tinker with that in future, but I'm comfortable with DOS 6.22, and I know what I'm doing, and I don't speak Japanese. So we're going to test it out with this. So we've seen the Mega Drive side, let's try out some regular PC games now. Who needs Sonic the Hedgehog when you can play a platform game with 286 power? And when you're playing Sonic, you don't have the satisfaction of enjoying the sound of that IBM keyboard when you play with the joypad. Oh, just listen to those keys. Although I did make the mistake of using the Google Translate app on those keys, and there's a few worrying translations on there. I'll try not to press the death key. The PC though is functioning just as you would expect any 286 PC to, albeit with VGA graphics, so we're spared from that CGA era magenta, which is what I normally associate more with 286s, because as we know, when the Teradrive came out, it really should have had a 386. It was the 386 era, but there was some cost cutting went on and we ended up with a 286 in it. And the frame rate in this game also highlighting why it would have been nicer to have a higher base spec for the system, as it really should have been in 91. So aside from the absolute delight of the machine working and the repair being a success, what we've seen so far is a Mega Drive and a PC being a Mega Drive and a PC. And we've seen that cool modern upgrade in the Pico Mem to make things easy. But the real question is this system integrated in any way? Now, this is the part of this series that I've been really excited about, getting stuck into the integration side of things. Is there anything truly unique about this that separates it from the Amstrad Mega PC? Can the two sides talk to each other or work at the same time? Well, now's the time to find out. And I do know that it comes with a game called Puzzle Construction originally, which has some kind of integration, so we'll check that out in a bit. But I've also been talking to a chap called RetroSwim down in Australia. Now, inspired by the first part of this series, he dug out his Teradrive and started poking around with it to see if he could figure out and answer those integration questions. And we're going to have a chat with him now and see some demos that he's come up with and hear how he went about it. So here's RetroSwim.
Greetings, I'm RetroSwim. I've been tinkering with the Teradrive since the first part of this series came out and set about creating some demos. I switched on my Teradrive, I booted into DOS, and I started using the MS-DOS debug command just to start poking values into the different I/O ports just to see what would happen. After a few hours. A few hours of not much traction. I finally got the PSG chip to make a beep sound, which is the square wave generator, and the response to that was pretty positive, and that sort of gave me the energy to turn that little experiment into the 2 demos that I've released. So the first demo is a Mega Drive ROM. It shows a sprite on the screen and some descriptive text that shows you, hey, this is the BIOS string that I found. So yes, you are running this on a Teradrive. Awesome. And then you can push some buttons on the controller to do some stuff. And one of those things is to switch the output of the system between the VDP, so the Mega Drive video chip, and the VGA, so on the PC side. And then the other buttons do some VGA stuff. They change the graphics mode. They do color cycling and some other just basic PC stuff, but enough to show that you can, what can sort of be done. And the other demo is a PC, like a demo that runs on DOS, and it just shows a screen on the PC side, just with some descriptive text. But if you push the buttons, if you push the Mega Drive buttons on the Mega Drive controller, you can affect what happens on the PC screen. So it's actually reading the controller from the PC side. And also it's playing music again to the PSG chip, because that's what I figured out. That's what I was comfortable with. So it's playing an old Sega Master System tune that a lot of people are probably going to recognize. Reading the controller and displaying a message on the screen, with a couple of sort of PC demo tricks thrown in just for a little bit of flair. I kind of thought that it'd be really cool if you had like an RTS game, right? Like a Warcraft style thing, and you could do your high level planning and battlefield preparation stuff and economy stuff on the PC side with a nice high resolution display and a mouse and keyboard, but then when you zoom into a battle, like on the scale of individual units, it switched over and used the Mega Drive hardware to like render hundreds of sprites and lots of colors and nice, bright, fun music and sound effects, because the PC side doesn't have any of that, right? It's got a VGA and the PC speaker. If you have the switch on the back of the machine in RGB mode, you can actually have the Mega Drive output on the composite port and the PC output on the VGA port. And the 2 CPUs don't run simultaneously, but if you're doing stuff in the VDP from the 286 side, you can see that happening at the same time that VGA stuff's happening. So, yeah.
Do go and follow him using all of the links and things that you see on screen and in the video description. Give him a big cave hug and carry on following the work that he does, because he's obviously a very talented chap and he's answered some questions for us here. But I've got some more questions, and those questions lie in any commercial examples that I could find to demonstrate the system, including that puzzle construction. So let's have a look at those now. And here it is. So puzzle construction, as you could easily guess, is a puzzle game. When we launch it, we see the sync flick on the screen momentarily, and we see the Mega Drive side of the system kick in. So something's happening there, despite there being no cartridge in the slot. The menu then pops up and it gives us the option to play the game. That's the first yellow tile. This is what it looks like. It's a basic Tetris-inspired puzzle game. You understand it. It's a pretty simple game. Nothing too exciting about it, but it is quite addictive. I did play it for some time. But there's no cartridge in, so it's obviously getting its data from the PC side. So there is a link there. The other menu options are a little bit confusing for me with their Japanese text, but there appear to be options to edit the rules of the game. That's this screen here. and edit the gameplay experience. There's also a layout editor to change how the game looks here. And there's a graphics tile editor where you can load tiles in and manipulate them with a very basic paint program. Now, none of this would have been possible on a regular Mega Drive with a read-only cartridge, so of course somehow the Mega Drive is loading the game and the assets from the data stored on the PC to the Teradrive. It's a Mega Drive with a hard drive, and it proves that there's a level of integration that's really quite useful, and real-world examples can be made with it on this hybrid system. Another example I found was in the game The Manhole. This was the precursor to the famous Myst game by the Miller brothers, and it was released on quite a few versions. This Teradrive version is based on the FM Towns one that came out in Japan, and it was discovered not so long ago by someone called Ziggy the Hamster and shared on archive.org. Now, what I noticed when you launch this game is that there's a batch file that first calls an executable called ATFM. Puzzle Construction also does this, but with an earlier version of that file. And if we run that executable with the S switch, we get the message Terra Security Unlock. So perhaps this is the key to opening up the ability to work across the platforms. Or perhaps the FM in the name refers only to the FM sound chip on the Mega Drive. I'm not quite sure what or how much this unlocks, but it's an interesting message. So to see if we can spot any difference, let's load the Manhole without the security unlock in place. Hopefully your ears aren't bleeding yet, but if we run it again with the security unlock executable in place, here's what happens. Glorious FM sound. This is a lovely example of an entirely PC game making use of the very exclusive features of the Teradrive to enhance it. The music continues throughout the game while you're playing in different areas, you get different tunes playing, but also you get the PC speaker audio when you encounter characters like this. And yes, that is still the PC speaker. This game used a clever method of forcing speech through the PC speaker. That really is the limit of what I can show you in terms of the system wielding 2 swords or 3 CPUs. Or now that we have a Pi Pico in there, is it 4 CPUs? As we established in part 1, it was doomed to failure owing to its underpowered 286. It could have been a great success if it had been packed in with a 386 for the same price. The Mega Drive was current gen when it came out, and the 386 would have catered to most, if not all, of your PC needs at the time. And the space-saving design is very appealing. Lots to do, but hopefully you've enjoyed the demonstrations and the repairs today to just get to know the Teradrive. And if you'd like to know anything specific about it or see more about it, then please do let me know in the comments. If you'd like to support what we do, please go to patreon.com/RMC Retro and sign up to be an official cave dweller and help us out. And if you don't want to do either of those things, please do just take a moment to subscribe to the channel and to give the video a thumbs up. I hope you've enjoyed this series, and I will see you in the next video. Take care, everyone. Bye-bye.